So we're here at Lowe's to talk about sprinkler systems. We picked Lowe's because it's the biggest system we have in town. It has 5 wet risers, it has 2 dry risers, and it has a fire pump. So we can show you every component there is, how to shut down a wet system, how to shut down a dry system, jockey pumps, air compressors, and a fire pump. If you understand this system, you can understand every system we have here in town. This has all the components you might see in other locations. So you can tell a building has a fire pump from the outside if you see one of these. This is what's called a test header, and the only purpose this serves is when the sprinkler company comes once a year to do their certification on the fire pump. They actually will attach a 2.5 hose to all of these to make sure the pump is still pumping at the capacity it was originally spec'd for when the building was built and the system was installed. So each one of these test header ports corresponds to 250 gallons per minute. So if we only saw 3 of these, it would be a 750 gallon per minute pump. So we have 250, 500, 750, 1000, 1250, 1500. So this fire pump is rated for 1500 gallons per minute. And I just know that from the outside for the test header. So although water comes out of this when we're testing it once a year, if there was an emergency, do not hook up to this and think that this is going to supply the fire truck with water. That's not what this is for. It's just a test header for the fire pump. Most sprinkler rooms should have a label on them. Some are accessible from the outside of the building like this. Others you do have to go inside the building. But if you have to go inside the building, per Bedford, you have to have a way to shut it down from the outside. So you might have a wall stem PIV, or you might have a yard PIV. This one doesn't have those because we have direct access from the inside. So regardless of what type of system you have, it all starts with the water supply. So we are on city water here at Lowe's, and you can tell that water is coming up from the ground, and the first set of valves you're going to see are these that are called main control. Sometimes you'll see one say city side and system side. Really there's just 2 valves here because this is a backflow preventer, and these valves need to be here to help service it. But if you were to spin either one or both of these wheels, you would shut off water to the system. So if the lieutenant tells you to shut off the main water, go to either one of these that are the main control and you can close down one or both. All valves will have something near them that looks like this. This is a monitoring module because the fire alarm system will actually supervise the sprinkler system. So if I were to turn this valve, this meter would click and it would send a signal back to the fire alarm system as a supervisory, letting me know that this valve is closed. And it would actually say main control 1, supervisory closed. So for this particular system, because we do have a fire pump, after our main control and our backflow preventer, you're going to see another set of valves. And if you actually follow this piping, if you ever get confused, always follow the piping. This one goes up and around and past our fire pump. So this serves 2 purposes. The fire pump will run itself once a week, kind of like a generator, to keep everything lubricated and everything running correctly. So this is kind of like our recirculation on a fire engine. So you pull your tank to pump, you pull your tank fill. This allows the water to move around because the system is still under pressure on our risers, hopefully. And if the fire pump did, for whatever reason, fail, this allows us to put water out and past it. We don't have to try to pump through the resistance of the fire pump. So that's really all that this is for, and you will only see these in systems where there is a fire pump like that. We'll zoom in a second, but this is the fire pump right here. So this is what creates the actual pressure. There's a few different types of fire pumps. This one's electric. They have diesel fire pumps, electric fire pumps, but they all work the same way. They obviously take water and they generate a higher pressure. We don't create gallons per minute, we create pressure, PSI, and that's their contribution to the system. So if you have a fire pump, you will also have a jockey pump. So a fire pump is monitored by a fire pump controller, which is over to my left, your right. The fire pump controller just monitors pressure and will engage if pressure reaches a certain amount. So a jockey pump keeps the pressure up to where it's supposed to be so that it never lets the fire pump controller think that it is at a low enough pressure that it needs water. But alternatively, the jockey pump is also undersized to a point where if a sprinkler head did go off and we really needed the fire pump to run, the jockey pump is not big enough to be able to keep that pressure. Eventually pressure would fall low enough that the fire pump would sense a condition that it needed to run and the fire pump would start running. So that's the jockey pump's one and only job, is to keep the pressure inflated so that this never runs unless it absolutely needs to. So this is an air compressor, and you don't necessarily see this every time you have a fire pump. We have some systems in town that do have compressors but don't have pumps. We have some pumps that don't have compressors. This is for dry systems. So a dry system works, there's a valve that there's air in the lines. And why do we have air in the lines instead of water? This is New England. That means the pipe is going somewhere where it could freeze and burst. So this keeps air on the side where it could be exposed to cold temperatures, and water stays in this room where it's warm. If the sprinkler head breaks, the air is released and it allows that valve to open, and water then fills the pipe and comes out wherever there's a broken sprinkler head. So they're not always this big. Sometimes you'll actually see them attached to the riser they're serving themselves. But the air compressor is different than the jockey pump we just talked about. This, all it does is generate air to keep it in the pipes so that we don't have freezing in freezing locations. So if you ever get confused about whether something's a jockey pump or an air compressor, just kind of look, this looks like your typical air compressor. And also, just follow the piping that's coming out of it. Do you think it's full of air or do you think it's full of water? Because if this is full of water, we've got bigger problems. So that should never happen. So over here, we have all of our individual risers. This system has 7 of them in total. We have 5 wet and 2 dry. How can you tell the difference? This is only found on dry systems, and that's that valve I spoke about. This is a clapper valve, they call it. So from here up, it's all full of air because these are going to areas that could freeze. We're at Lowe's, so there's a lawn and garden section, so it's probably covering that. It's probably covering the loading dock. I can actually read the individual labels. But again, you'll only see this on our dry systems. I have one here, and I don't know if you can get it over here, Eric. There's a big flapper over here as well. So these are our 2 dry systems. We got air above, water below. All of our other systems are wet. These are full of water all the time. Now, let's say the lieutenant wants you to shut down an individual zone, not the entire system. That's what these are for. You'll notice that each riser also has multiple pressure gauges. On our wet system, we'll get a zoom in here in a second. On our wet system, the gauges are always going to match the pressure. However, on a dry system, the gauges are significantly different. Here, I have about 48 psi of air holding back 160 psi of water. So if you ever find a dry system where both of these gauges are matching, that means the valve has let go and your system is charged. Another big difference between wet systems and dry systems, wet systems have flow alarms. So when water is actively rushing through the system, it's spinning a wheel that comes in as a flow alarm on our fire alarm panel. It makes the electric bell ring. But when water is just sitting still in the pipe, no issue. On a dry system, it doesn't have a flow alarm, it has a pressure alarm. So remember I talked about this is only 48 psi, that's pretty low pressure. When the pressure is higher, like that 150, it goes into a flow alarm then, even if water is not moving, because sometimes these valves can just open without a sprinkler head being broken, and it's going to show as a flow alarm even though no water is moving. So the only way to reset that is you have to get pressure off of that switch. So I would have to shut down this switch, and then here's my main drain. I would have to get all of that water out of that pipe in order to get that pressure switch to stop. I could go sit at the fire alarm panel all day hitting reset. It's never gonna take a reset while there's pressure on that switch. So remember, wet systems have flow alarms, dry systems have pressure switches. So if you ever have a question about where systems go to, you can actually read on this hydraulic system, the sticker. So these are not for the fire service though, these are for the sprinkler companies. Don't worry about any of the figures that are on here, but it will say what system it's covering, and that's based on how it was designed by the engineer. So this dry system is going to the garden center. That makes sense, it's outside, so that's why I've got a clapper valve. Over here, this system, it says northwest sales area, that's a wet system. Southwest sales area and office area. This one's system 6, it says shade structure. I don't know what that is off the top of my head, but obviously it's in an inclement location because we got a dry valve, so this is a dry system. System 1, sales area, rack system, they're paint racks, and system 2, southeast sales area. So it's not always a perfect science. There are limitations to the size of the systems you can have. So some smaller buildings might have only one riser, one system. But this one, like some others, have multiple. So like I said earlier, we have 7 total, we have 5 wet systems, and we have 2 dry systems. And that's really about it. The fire pump, it looks big and complicated, but it's just here to add some pressure. So if you do try to shut down a system that does have a fire pump, it's important to also shut down the fire pump. Remember, this runs off of pressure. When it senses low pressure, it will begin to run. So if you shut down the water, it's gonna sense low pressure, and these things are called sacrificial pumps. Kind of like our engine, once we put it in drive or that 4th gear and we engage the pump, even if it gets low oil, it gets high temperature, it will run until it explodes or somebody shuts it off. So it's important that we shut it off. So you have to shut off both the jockey pump and the pump controller because they will continue to run until they achieve the pressure that they want. And if we have a vent here, we're not going to be able to achieve that pressure. So the jockey pump controller is over here. It's in the on position. It's pretty easy. You just turn it to off, and then there's an auto position here. I can turn that to off. Same thing with the fire pump controller. Some of them have different buttons. They're made by different companies, but the important thing to remember is if I hit stop, that's only going to stop it temporarily. As soon as this thing resets itself and realizes it has low pressure, it's going to fire again. So there are some that have auto stop off. Do that. This one, the gentlemen who work on the system were kind enough to just label step 1, step 2. We're just killing the circuit breakers to the fire pump. No power, it's not going to run. So that's how you shut down the water and the fire pump for a system that does have a fire pump.